Welcome to The Explainer. Ever had a daydream so vivid you wondered, could this actually be something? Well, today we're diving deep into that exact idea. The hidden and honestly pretty amazing connection between our wildest imaginations and real hard science.
I mean, it seems like they're from completely different planets, right? On one hand, you've got fantasy, pure imagination. On the other, you have rigorous, logical, data-driven discovery. But what if they're not opposites at all? What if they're just two different stops on the exact same journey? Okay, this quote is really our launching pad for today. It's a powerful way of thinking about it. All the stuff we learn, all the knowledge we soak up, that's just potential energy sitting in our brains. And research? Well, that's the spark. That's the moment that potential gets turned into kinetic energy, into action, into discovery. So, how do we actually make that leap from a daydream to a real discovery? It all starts when you realize that every single way we ask questions exists on a spectrum. Yep, from that random thought you have in the shower all the way to a multi-million-dollar lab experiment, it's all part of the same process. Now check this out. This table gives us a fantastic map of that journey. You've got casual research on one end, that's just pure, spontaneous curiosity. Then way over on the other end, there's formal research, super systematic, rigorous, all about proof. But look what's right in the middle, science fiction. It's not just entertainment, you know, it's a crucial middle step where we play with ideas with a sense of awe and wonder. And this slide just breaks it down perfectly. Think of casual research as your brain in dreaming mode. It's messy, it connects things that don't seem connected, and it lets you test drive the wildest ideas with zero risk. Formal research? That's your brain in waking mode. It's focused, it's disciplined, and its job is to take the best of those dreams and see if they hold up in the real world. This puts sci-fi in such a fascinating light. It's not just escapism, it's a narrative laboratory. It's our shared, collective dream space. Before we actually build the super smart AI or figure out warp drive, we run simulations in our stories. We explore what could go wrong, what could go right, and get our heads wrapped around what the future might actually feel like. So, okay. We have wild imagination over here, and we have formal, rigorous science way over there. But what's the bridge? How do we get from one to the other? Well, a couple of new theoretical frameworks are trying to build that very bridge. Let's get into it. First up is the Brain Kinematics Model, or BKM for short. Honestly, the easiest way to think about it is like a universal translator for your inner world. It's designed to take all that fuzzy, symbolic language from our dreams and feelings and translate it into concepts that scientists can actually measure and model. It's literally trying to turn poetry into an equation. And then you have continuity theory, which zooms all the way out. I mean, we're talking big picture here. This is a massive idea that suggests maybe there's one single underlying set of rules for everything, from the physics of a star to the psychology of a thought. It's a hunt for the master blueprint of reality itself. But here's the catch, right? Anytime you have a huge, ambitious new idea, especially one that starts from something as personal as a daydream, it faces this massive challenge. How do you prove you're on the right track? How do you know you're not just making stuff up?
And that is the absolute key question. When a theory tries to build that bridge from pure imagination to hard data, it's standing right at a fork in the road. One path leads to legitimate, testable science, and the other path, well, that one leads to pseudoscience.
Now this is what's so cool. The creators of BKM are actually asking themselves these hard questions, out in the open. They are embracing the self-critique. They're asking, are our definitions crystal clear, or are they kind of vague? Can we actually test this, or are we just telling a good story? And maybe most importantly, what do we do when the data contradicts us? Do we adjust, or do we get defensive? That right there, that's what separates the real science from the wishful thinking.
So, the best way to keep yourself honest and avoid just spinning stories is to have a concrete plan, a public plan. And for a theory like BKM, there's a very real roadmap designed to drag these incredible, imaginative ideas into the harsh light of a laboratory.
And this isn't just some vague, we'll get to it someday thing. It's a step-by-step plan. You can see how it builds. First, you lock in the definitions, no fuzzy language. Then you make real predictions that can actually be proven wrong. You start small with pilot studies, and then you scale up to the big guns, the heavy-duty brain scanners. It's the slow, methodical, essential process of turning a dream into data.
So after all of this, what's the big takeaway? Why does any of this matter? It's that every single stage of how we think, From the most out-there fantasy to the most boring data point, every piece has a vital role to play.
This whole thing is really a beautiful evolution. It's a journey that starts with an emotion, a gut feeling, a daydream, a story. But with discipline and rigor and collaboration, that spark can be shaped and refined until it becomes a verifiable, measurable truth about our universe. It's the journey from emotion to equation.
And that's the crucial point. Real science doesn't just spring to life in a sterile lab. It begins in the messy, chaotic, and absolutely wonderful world of the human imagination. It begins the moment we dare to dream.
Which leaves us with one last, pretty exciting thought. If the only thing standing between a fleeting daydream and a world-changing discovery is a process, then what incredible new futures are hiding in our imaginations right now, just waiting for us to begin?